In event-driven architecture, each component of application logic emits events, which other parts of the application respond to. We have examined this pattern in previous shows that focus on pub/sub messaging, event sourcing, and CQRS. In today's show, we examine the intersection of event-driven architecture and serverless architecture. Serverless applications can be built by combining functions as a service like AWS Lambda together with Backend as a service tools like DynamoDB and Auth0. Functions as a service give you cheap, flexible, scalable compute. Backend as a service tools give you robust, fault-tolerant tools for managing state. By combining these sets of tools, we can build applications without thinking about specific servers that are managing large portions of our application logic. And this is great because managing servers and doing load balancing and scaling is painful. With this shift in architecture, we also have to change how data flows through our applications. Danilo Poccia is the author of AWS Lambda in Action, a book about building event-driven serverless applications. He also works at Amazon Web Services as a developer evangelist. In his book, he discusses the connection between serverless architecture and event-driven architecture, and we explore that here as well. We start by reviewing the evolution of the runtime unit, from physical machines to virtual machines to containers, and now to functions as a service. And then we dive into what it means for an application to be event-driven. We explore how to architect and scale a serverless architecture, and we finish by discussing the future of serverless, how IoT and edge computing and on-premise architectures will take advantage of this new technology. Auth0 makes authentication easy. As a developer, you love building things that are fun, and authentication is not fun. Authentication is a pain. It can take hours to implement, and even once you have authentication, you have to keep all of your authentication code up to date. Auth0 is the easiest and fastest way to implement real-world authentication and authorization architectures into your apps and APIs. Allow your users to log in however you want. Regular username and password, Facebook, Twitter, enterprise identity providers like AD and Office 365, or you can just let them log in without passwords using an email login like Slack or phone login like WhatsApp. Getting started is easy. You just grab the Auth0 SDK for any platform that you need and you add a few lines of code to your project. Whether you're building a mobile app, a website, or an API, they all need authentication. Sign up for Auth0, that's the number 0, and get a free plan or try the enterprise plan for 21 days at auth0.io/sedaily. That's auth.io/sedaily. There's no credit card required, and Auth0 is trusted by developers at Atlassian and Mozilla and the Wall Street Journal and many other companies who use authentication. Simplify your authentication today and try it out at auth.io/sedaily. Stop struggling with authentication and get back to building your core features with Auth0. Danilo Poccia is a technical evangelist at Amazon Web Services. He's also the author of AWS Lambda in Action. Danilo, welcome to Software Engineering Daily.
Hi, Jeff. Thank you for inviting me.
It's great to have you because we are going through this transformation where cloud computing is going from the runtime unit, from the container, becoming the runtime unit of serverless or functions as a service. It seems like we've gone from virtual machines to containers, and now we're going to functions as a service. Describe this evolution as you see it. Why are we evolving in this direction?
Well, what I've seen is that developers, they want to go faster. They want to gain more speed. So I think this is what is behind this move. So with virtual machines, everything you do, it's in a matter of minutes. With containers, in a matter of seconds. With functions, it's even faster. You enter into the milliseconds range. And this is really, so it depends on where you want to spend your time. So what is your interest? So if you want to do the fine-tuning of the kernel of the operating system, then probably you need virtual machines. If you still want to manage a cluster of application components, then containers with a management platform, they are great, of course. But with functions, you can really focus on the code that you write, on what you want to build.
Mm-hmm. With virtual machines and containers, we have a stateful execution environment. We've got memory, we've got a file system. It feels like classic computing. How does our thinking about applications need to change given the fact that we're going to serverless, and in serverless we have a lack of state because we're not addressing an actual box. We're just throwing a function up into an anonymous blob of compute somewhere.
Yeah, personally, I think stateless is good. It's a good architectural pattern. So it's something that I would suggest even to people that is working with different architecture. It's good for scaling and for availability because it's much easier to manage the scaling and the availability of something that doesn't need to keep a state. And state should be normally managed for a distributed architecture differently. So each service of for example, a distributed architecture should keep its own state inside only if needed. And then you should think that since the architecture is distributed, things are different than with a monolithic application. You should think of things like eventual consistency, so data will slowly converge into a final state. And also you should build all the interface that you design, if possible, as idempotent, so that if the same data comes again, then you get the same result. So idempotency and eventual consistency are probably two ways to overcome this limitation.
When we're using serverless, that means that we don't need to care so much about load balancing or auto-scaling groups or capacity planning. That's one of the set of advantages that people have said in previous episodes that is really valuable about serverless. And serverless when we're talking about functions as a service, it may be hard for some people to understand because it's like a paradigm shift where it's not pure upside, it's not pure downside, it's just a different paradigm, and you have different advantages and disadvantages. Help people understand what are the upsides and the downsides of moving to serverless.
Well, the upsides, I think it's, as I said, you can focus on on the features that you want to build, not the boring stuff. You don't pay for idle, and you pay very little for small workloads. So this is fostering experimentation, so you can build a prototype, innovate. So if you're a startup or even if you're a large company, you can quickly build a prototype, test it, and you don't have the economic impact of building something if it doesn't work. And running experiments is really the only way to build something new, to innovate. And also, I think there's a big advantage in security because security is part of what you build. It's you're forced to give permissions to a Lambda functions. You have to think about permissions, and this is different from when you start creating something locally on your laptop. Mm-hmm.
And so, as we have to make this paradigm shift, maybe you don't want to call it downsides, but it seems like there are some shifts in thinking that we're going to need to make because we're not deploying our applications. You're not writing a big Node.js application and deploying it, and then it just stays up and running for a long time. It's kind of a different world. So how does it contrast? What are the paradigm shifts that we need to make as we start to build in a world of functions as a service?
As you said, it's a new approach. So you need to understand it so that you use probably a different mindset. It's a distributed architecture, so everything that runs inside functions, you can control, for example, the order of delivery of messages in some components. You have to think that the availability is managed by the platform, but you still need to program how the logic flows, so what are the relevant events that should trigger your function. So I think the downside is really thinking in a different way. That's why, for example, in my book, I have a long tutorial spanning across multiple chapters of building a simple media sharing application where you create a user, you validate the user sending like an email to test the email address, and then if the user is okay, you can start uploading pictures and so on. So this is a slow tutorial that it's not really focusing only on the technical side of it, but really in thinking in the right way.
Yeah, it's like a different set of constraints, and I think they're, in many ways, very healthy constraints. Sometimes constraints can really help you go in the right direction. You mentioned security advantages. The lack of servers means that we don't have to worry about our servers getting logged into and misappropriated. The serverless functions as a service and the other platform as a service, things that we might use to wire our application together, they have a very specific set of functionality. So if our units of functionality have more narrow scope, they can't be told to do things that we don't want them to. These are some security benefits. What are the other security implications of functions as a service?
Well, the operating system and the programming framework, so the runtime you want to use, like Node.js, Java, or Python, they are taken care by the provider, by AWS in the case of AWS Lambda. So you don't need to do the patching of the operating system, for example. You only need to look at patching your code and the dependencies, the libraries, the modules that you bring with your code. And the narrow scope that you mentioned, the fact that each function is usually covering only a smaller, narrow scope, can help you embrace the principle of least privilege. This is a security principle that tells that every module in your application should only have the minimum amount of privilege that they need to perform the action they're supposed to do. So, for example, if you build a customer service application where in some way sometimes you need to refund money to your users, you don't need to give the permission to give the refund to everything that is running inside the customer service application, but only in a specific function that will be the refund money function.
Mm-hmm. Your book focuses on event-driven applications in much of the narrative. When we're talking about event-driven applications on this podcast, sometimes people don't really know what that means. Like, what is an event? Because most people are building these imperative applications where you're making calls, explicit calls to a function, and it feels, like you're writing the script for what's going on. An event-driven application feels like more of a responsive, reactive application. So I want to help disambiguate what this means for people. What is an event?
So if you look at the definition, an event is like something that happens or something that takes place. And in the sense of a computer application, an event is telling you, the list of events is telling you the history of what happens. So it's telling you the history of everything that happens inside your application. So for example, a file has been uploaded by your users, or some part of the application has updated a database table, changing some values. And each event by itself is interesting because it's immutable, because it's telling you that something happened. It's not something that is going to change. And in distributed application, immutable data is always easier to manage than something where you can have concurrent access.
Mm-hmm. And what does that translate to in terms of an application? What is an event-driven application?
It's an application where the business logic executes in response to the events that are received. As you said, it's a reactive architecture because you are reacting to an event. In some ways, bringing the reactive programming approach that normally we use in the front end to build the user interfaces into the backend, I would say finally. Mm-hmm. And what I like to think is that the event is like the cause of something, and then the logic that is executed is the effect. And if we start thinking of this cause-effect, so event and logic, they are the cause and the effect, it's much easier for our minds, for our brains to understand how an event-driven application works, because cause-effect is something that we are used to look into anything since we are a child.
Tell me some of the implications of that change to a cause and effect driven application. Why is that useful for a serverless environment?
It's not useful at single function level, maybe, but it's useful when you start to design an architecture that is more complex than a single function. Because you start to think, you look at for example, at the data of your application, you start thinking, what happens if something happens here, like a new file has been uploaded, or a new user is inserted in the database, or a new item is inserted in the shopping cart of my e-commerce application. And then you start to think, okay, if this happens, then I should do that. And in this way, you start thinking, of course, in event-driven architecture, but also you started to link the logic of your application with the flow of the data.
This episode of Software Engineering Daily is sponsored by Datadog, a monitoring platform for dynamic infrastructure and applications. Datadog integrates seamlessly with more than 200 technologies, including AWS Lambda. After just a few lines of instrumentation, you can get insights into your serverless applications with powerful dashboards and machine learning-based alerts. Start a free trial today, and Datadog will send you a free t-shirt. Visit softwareengineeringdaily.com/Datadog to get started and get that free t-shirt. Again, that's softwareengineeringdaily.com/Datadog. So there's a typical pattern for event-driven computation, and you've talked about this in some of your presentations that I've seen, where, for example, a front-end app like my mobile application, let's say my media sharing or my media consumption application. I've got a video player application on my phone, and it makes a call to a serverless function, and the serverless function makes a call to a database like DynamoDB, and then that change to the database, like let's say I'm playing a video, and so DynamoDB registers that I have just played a video, and that changes to a database trigger, that change results in a database trigger, and that trigger leads to another serverless event. So here we have a cause and effect relationship, a series of cause and effect relationships. User requests a video, database updates, database causes an event, change to the database triggers another event. That event propagates to another serverless function, and we can start to see how we can have a chain of cause and effect leading to broader functionality. Maybe you could give a more full-fledged example, since you spend a lot of time talking about this, where we might want to use this pattern.
Oh, there's lots of use cases. A very basic one, similar to what you described, is when you create a new user. So you can have a create user function that writes the new user data on the database. And so it can come from a mobile application or it can come from a web application. And this triggers another function. So the fact that you insert the user data on the database, you can trigger another function that can verify the data, can, for example, depending on the content, send an email to verify the email address, or a personalized welcome email based on the interest that you flagged when you sign up. So this is a very simple use case where you chain a function, a database trigger, and another function. More interesting use cases I've seen is, for example, in data processing. So maybe you receive a stream of data. Each data point can be processed as an event or grouped in micro batches. And after you insert a data point, for example, that is coming from, an IoT sensor, you can have a function that is triggered, is looking for the last 10 minutes of data points sent by the same sensor and can update some statistics that can give you like the minimum, the maximum, the average, or something like that on the data reported by this sensor. And moving forward, you can build even more interesting architecture that where the Lambda function that is triggered can look at a set of data and do anomaly detection, understand, for example, is a sensor that is deployed in the field is working correctly or not.
Mm-hmm. Right. Yeah, and how would you contrast, maybe you can take one of those examples and contrast how the architecture might work with a monolithic or a different deployment unit. Like if we were deploying to a virtual machine or a container, what would make that architecture more difficult to manage?
You mean more difficult to manage in a serverless use case?
No. So in the serverless use case, why is it advantageous? Like, why is it better that we're deploying this to this cause and effect serverless composition world?
Because it's completely natural to the architecture. Because when you create a function, a serverless function, it just sits there. It doesn't. There's no way to call it if you don't link this function to an event. It can be an API call, it can be an update on the database, as I said, but you need to think of this trigger. And this brings you to thinking in a different way.
Right. And I guess you don't have to stuff... Sorry, go ahead.
No, I was thinking that this is at single function level. If you start to have lots of functions, then you need it's good to design the overall architecture, how all the flows goes. But you also need to have everything inside a single description of all your functions, of all your event-driven architecture in a single repository, such as a single template file. And that's why there are tools that came from the open source, like the serverless framework or Terraform. As AWS, we released in open source the serverless application model. It's an open source specification that extends and simplifies CloudFormation for serverless use cases. So you have a single template file that describes your functions, how they correlate with the other repositories that you have, like S3, DynamoDB, other databases. And then you can use this template with your source code to recreate the overall architecture.
Awesome. Yeah, you're describing how we start to manage this world, because people who are a little afraid of this might think, oh, we've got 5 or 10 different serverless functions that are all wired together, and these are replacing my monolith. And I'm very comfortable with my monolith that has all of these functions in one place. Talk more about how we manage all of these functions, how we compose them together and keep track of what's going on when we're moving out of the the world where we've got all of our functions defined in a single node application that we can just deploy to a container and we can easily understand. How do we keep track of what's going on?
Well, from a practical point of view, you should have this central template that can help you keep track of what functions you're using, how they relate one to another, and to the data repositories that you have. And so you can use serverless framework, AWS SAM, Terraform. This is probably something that I would strongly suggest. Don't work creating by hand one function at a time, because you can lose track of what you're building. So having a central repository helps. And then you should have the right mindset. As we said at the beginning, you should start thinking in a different way. And for this reason, I created an open source tool that is available on my website. It's called Serverless by Design. And the website is serverlessbydesign.danilo.net. If you go on this website, you can really graphically design as an event-driven architecture. So you can create your repository, your object, your functions. Then you can connect one repository to a function so that it's triggered if something is changed, for example, in a database or you get an API call. And the idea behind this tool is really because I want to give everybody a tool so that they can quickly prototype, quickly design, and start thinking in this way.
It's a great tool. I've seen it, and it's sort of like the UML that we always wish we had. It's because the problem I remember. I think the problem with UML has always been that you take a look at it at a UML diagram, and it sometimes is confusing what's going on. You've got maybe triangles or boxes, or you've got a diagram that you've got a little symbol that looks like a database, and that's very easy to understand. But when you start to get into components with richer functionality, it's unclear what each UML diagram is supposed to represent. But if you're doing it with, if let's say your entire application is architected in AWS, AWS has those nice little symbols for each of the different services. So if you're making a UML diagram that's basically AWS services wired together, it can be easier to understand what each of these modular units is, because it's just an AWS service.
Yeah, this is definitely more colorful than a UML diagram. But yeah, apart from that, I think when you create a user interface for developers, you need to think that developers, they know what they want to build. And if you start to put too many features, so if you reflect all the possibilities, all the configuration possibilities that you have in the user interface, then you make the user interface too complex to use, and the developers start just using the text files as usual. So what I did is to get something very, very easy to use. I take a lot of assumptions when you create these diagrams, so that I don't need to ask 10 questions every time you deploy something graphically on the architecture. And I think that's why it's interesting. And this is something that you should always think when you create a user interface for developers, that it should be easier to use than the text files.
When I'm building a traditional monolithic application, I'm oftentimes building that application out of libraries that already exist. I'm depending on certain libraries, and you can end up with complex dependency graphs where I build one system that depends on another, and then I build another system on top of that that depends on the previous system. When we're breaking down our applications into serverless functions, how does the notion of dependencies and dependency graphs change?
Well, at some level, you should think similarly to what you would do in microservices, even if this is, of course, a little bit more extreme, more smaller components. So the same guidelines work. And then inside each function, you can bring your own dependencies. I usually suggest to only bring the dependency you really need so that you can keep the function smaller. But every function can bring its own libraries, can be binaries. So with AWS Lambda, for example, you can bring binaries. I have an example that is on the website that I created for my book where I use OpenCV. That is the Open Computer Vision library. It's a C++ library that I compile statically and brought together with the Lambda function, and then I use it through their JavaScript and their Python endpoints. So this is from a technical point of view. And then from more an architectural point of view, what I did, for example, with the tool that I created with Serverless by Design is really to map an architecture into a network model with nodes and edges, so a formal mathematical network. And that was an idea that it was with me since last year. It was, I think, at Serverless Conf in London. And I had this idea that every event-driven architecture could be mapped one-to-one to a network, where the nodes are the functions and the data repositories that you have. And then the interaction between the nodes can be a verted graph, so a verted network.
When we're architecting our applications, how do the backend and the front end responsibilities look in an event-driven application? Like, how can we start to think about architecting what we would traditionally call the front end and the back end?
So my suggestion is to take this to create like a standard interface between these two words so that they can communicate through a stable interface. So usually you would put an API gateway. And the API gateway can map API calls into the execution of one or more functions. And you can start using the API gateway with mock implementations, and then you can start so that the front-end team that can be working on a native mobile app or on a web or hybrid application can work on the mock implementation and start creating the client, and then the backend team can implement the integration between the API gateway and the Lambda functions, for example, one by one, so that you can implement the right functionality, and then you can integrate the two to have a test.
For people who haven't built these kinds of applications, explain in a little more detail what an API gateway is and how you're interacting with it as a developer.
So the API gateway is a place where you can design a web API, usually a REST API, but you can even go beyond the default REST model. So you give a web interface to the functions that you implement in the backend. Normally, you want to model a good API. You want to create a good API model because that's like a contract between the backend and the front end, and you don't want to change it if it's not really a requirement. So you should spend some time in defining the right API interface. So, for example, you can have you should look for what resources you need to manipulate from the front end. You probably want to create, users, and then these users can have a shopping cart, and then they can put items in the shopping cart. So this will be the three resources that you model, and then on top of these resources, you should create HTTP interface so that you can create a new user, update a user, delete a user, add content to a shopping cart, and so on. Usually, with the REST model, you use the HTTP methods to do so. So that, like HTTP GET, it's used to get a result. HTTP POST and PUT are used to create a new object, a new resource, or to update one that already exists. And in this way, you create an HTTP interface that is like a contract, and then you can start implementing on both sides in parallel.
When you start with a API gateway that is the central routing point for all of your application logic, let's say you start a company and everything is managed in that single API gateway. But then your company gets huge, and you realize, oh, I've got all these different departments and all these different companies. These, like, if you start with a book selling company and eventually you branch into all these other things, do you create more API gateways and then you have a central API gateway that routes to another API gateway?
One side of this is how you manage this as an infrastructure, and that's something that depends on on what you're using. But generally speaking, each microservice that you want to build should have their own interface, probably their own endpoint. So what that normally means that you can create one API gateway that is managing multiple services, or one API gateway, depending on implementation, can manage a single service. But the important thing is that each service has their own endpoint, because each service should be in charge of managing their own interface, their own contract with the consumer of that API.
Okay, I see. Okay, so after you hit this API gateway, different requests are going to get routed in different directions. Let's say some of the routing logic hits a function as a service, and the function as a service triggers some small amount of processing, and then it goes to a database. And there's lots of different backend databases that we can use to give us some stateful functionality. I mean, I think the way that we look at these applications, a lot of the ones that you talk about is you treat the function as a service for doing this ad hoc processing, and then you have these really rich databases that we have today. And these databases have really nice APIs, and then the databases can generate events that can, right after you write something, it's like the database calls back, and you continue this cause and effect relationship. Describe how we think about these different databases. What are the different databases that we use for, or maybe database is too specific a word. You could almost say data store, because like Redis, for example, is not exactly a database. It's a in-memory storage solution. Describe some of the different ways that we're managing state, because we're not managing that state in a stateful function application. We're just reserving the function as a service for this transient processing. So what are the stateful data storage solutions that we're using for different parts of our application?
Normally there is like this relational world and this NoSQL world where you can have multiple kind of databases, such as graph databases, document-oriented. It's really not different from a traditional application. So you should really find the best data model for your application. Normally, what I suggest is start to look how much your data is structured or unstructured. So if you have a very structured data set, then you can go more towards a more rigid database, even relational. Or if it's completely unstructured, like you can have text, media content, binary content, then maybe you can go to an object store like Amazon S3, for example. And then you can also integrate non-standard database with the serverless world. So, for example, for any database you have access to the transaction log, you can very quickly create a plugin that can trigger a Lambda function, for example, or a serverless function in general, if you have like something happening in a transactional log of a database. So you can really choose the database you want. Some of those are already integrated, and the choice between relational or NoSQL is really depending on what you need to build. If you don't have lots of relational dependencies across multiple tables, then I would go for a NoSQL like DynamoDB, because it's much easier to scale.
The devices that are accessing our services, like my iPhone, for example. My iPhone's got a reasonable amount of space. It's got memory. It's got essentially disk storage. How much state do you want to keep on client devices? Or does that story change at all when we're talking about a serverless environment?
I don't think it's really changing. I'm a great advocate of putting all the logic and all the data that is possible on the client, on the front end, and only use the backend when there is a compelling reason. And normally there are like 4 main reasons why you need to put data or something in the backend. So either you need to share data across different devices or different users, and then of course you need some point in the backend. You need to backup data because you can trust the robustness of the device. Or you need security. For example, if your application is, you have some payments in your application, you can't trust probably the client to take track if you gave money to someone else or not. You need like a centralized payment service in the backend or a distributed ledger, such as a blockchain, to take trace of that. And the final reason I find is usually if you need more computational or storage capabilities, that what's inside the device. And even if now smartphones are much more powerful than they were a few years ago, you still can go beyond those limits, especially if you start to do fancy things with probably artificial intelligence and machine learning. And also, this is very important for less capable devices like IoT, wearable. If you go in that space, then probably the devices that maybe needs to run on batteries, they don't have the computational capabilities or the storage capacity that you need, and then you need a backend for that.
Do you have a product that is sold to software engineers? Are you looking to hire software engineers? Become a sponsor of Software Engineering Daily and support the show while getting your company into the ears of 24,000 developers around the world. Developers listen to Software Engineering Daily to find out about the latest strategies and tools for building software. Send me an email to find out more. jeff@softwareengineeringdaily.com. The sponsors of Software Engineering Daily make this show possible, and I have enjoyed advertising for some of the brands that I personally love using in my software projects. If you're curious about becoming a sponsor, send me an email, or email your marketing director and tell them that they should send me an email. jeff@softwareengineeringdaily.com. Thanks as always for listening and supporting the show, and let's get on with the show. Yeah, wow, what a great explanation of, how to, that was a great set of rules for how to decide, what you should put on, what logic you should put on your client, what you should put on the server. We're going to need some notion of identity to do sessions for our serverless applications. How does identity management work in the world of serverless cause and effect, event-driven applications?
It's in a way similar to what happens in microservices. Now, in microservices, you still need to trace the identity and the authorization of the user across multiple services. On AWS, we have a service that can help you do that. It's called Amazon Cognito, and you can use it to federate with other platforms such as Twitter, Facebook, or with standard protocols such as SAML or OpenID Connect. Or you can also manage your own user pool and the lifecycle of the users with Cognito. Or we can work with partners like Auth0, Okta. So the idea is that you start getting an identity. This identity is mapped. You use it for authentication at first, and then this authentication can be mapped at any component with different authorizations. And then this can be managed depending on the service inside the logic of the function or in the service itself. We have for example, on AWS, you can really fine-tune the level you access DynamoDB, a DynamoDB table directly from a device, from a mobile application, so that you can read or write without any server in between, because you can say only this user can access this table, and this user can only access the items in this table, where his user ID is in the hash key, so in the main key of the item. So it's quite complex, so I'm not entering into too much detail, but the idea is that the services themselves can sometimes give you the feature to trace the identity and give permissions.
Okay. So I don't want to go past your area of knowledge, but in that kind of world, so like Cognito, is Cognito doing the session management and it's maintaining, okay, is this person's authorization token still fresh enough?
Yeah. You can get JWT tokens for example, from Cognito user pools, and those they have a validity, and then they can give you the endpoint to manage the refresh of the session if you want. So you can really build a session management platform and federate this with external identities if you want, or manage your own users.
Okay, that's cool. We've done series of shows about companies that migrate to some sort of container management platform. Some of them use Kubernetes, some of them might use Amazon ECS, some of them might use Mesos, but in any case, a lot of companies, they migrated from a place where they were just using VMs or they were just on, real bare metal servers to a place where they were managing things in containers. And maybe they were managing them in the cloud, maybe they were managing them on premise. And now they're looking at this serverless world and they're thinking, well, I can save maybe, for some domains of my application, 80%, 70%, 60%, 50%. I can save a ton of money by moving to serverless, and I can, help make my application easier to scale. What's the process of that migration? How is a company that has been building into this container world, or maybe they're still just on-prem and they have a monolithic situation, how do you begin to migrate your infrastructure to this serverless world with the appeal of the costs and scalability and all this stuff?
First of all, I'd say that most customers that migrate to the cloud and specifically they want to use serverless, is more to gain agility. It's not just the cost saving, it's more the agility, the capability to develop faster and especially to move what you develop in production faster. But when you have an architecture that you want to migrate to serverless, some of the initial thinking points are the same as when you want to migrate a monolith to microservices. You should start thinking what are the right boundaries where you want to peel the onion, not like create an isolated component. And the idea is, like for microservices, you should think really of business drivers, not of technical drivers, because business drivers will probably be the same across a longer amount of time, and you don't want to have the requirement change while you are developing something. So you should look like, okay, maybe the inventory, the product catalog, the user management, this should be separated by the overall application that I have. And then, technically speaking, with the serverless architecture, you can start using the API gateway. So you can put an API gateway in front of everything. At the beginning, it will be mostly a reverse proxy that can help you with advanced features such as throttling or authentication. But you can already put it in the front. And then, when you have a standard interface with the consumer of the application, of the backend application, so I'm talking about APIs, you can start taking one component at a time. My suggestion is start at first with something easy to migrate, like something that it's maybe with low risk and low dependencies, so that you can start understanding the tooling that you want to use, how that maps with your own internal process, because any company has different development pipelines that they want to build and use. And then after you start being successful with your first component, then you can start to look for something that is maybe creating some problems right now. Maybe there's these features that it's 2 years that you want to move in production and you've not been able to, and you can start looking into a more interesting use case for your next serverless experiment.
Indeed. Once we start to move to the serverless environment, how does our testing and debugging cycle work?
You can test locally if you want. There's lots of tools, and we released recently a tool that is called SemLocal. It's on GitHub that can help you to test locally your APIs, endpoints, and your functions, for example. But I think that lots of people doesn't remember that we started to have a scale, like a simplified testing environment, because in the past the production environment was too expensive. But now with serverless, you can create a complete replica of the production environment with almost no cost, because the test environment, unless you're doing performance test, will be almost idle. I think this is something that you should leverage. So you can test local, but do unit testing also in the same environment where you would do the production. When I say the same environment, I don't mean really that must be the same production website, but can be a complete replica, but using the same core services. And then when you need to go beyond unit testing and you want to do some integration test of how everything works, you can use synthetic transactions, something that can test how the data flows across all the components that you have. My suggestion, and this is something that where I've seen lots of customers going, is test in production if possible, even if it sounds crazy. But look for small changes so that every time you do something in production is a small change. Do A/B testing in production so that maybe you do like a blue-green deployment where you keep the new deployment, a new version for a small subset of your users, and then you can get some metrics, even business metrics, to understand if the new deployment is working, and then you release it to all your users. And this is something that we're also looking at, and we also pre-announced some new features for AWS Lambda in the Serverless Conf that we did in New York City, that was in New York City in October.
I want to talk about more far-flung concepts. The current model of compute is that we interact with a front end from our smartphone or our laptop, and then the back-end execution happens on servers in the cloud. But we're inching towards a world where there's going to be so many more devices where we could have processing occur. So we could have smart earbuds, we've got smart glasses, we've got a watch, we've got a drone outside our window, we've got a smart car on the street, maybe our shirt has a processor in it, and all of these computers can execute code. How will that change the current model that we have, where we see the front end and the back end as these binary, well-defined areas of compute?
Yeah, I think we're going into something different now. There's a lot of discussion around this edge computing term with not a clear definition, as often happens. My idea is that the logic is going to get distributed more and more outside of traditional data centers. So you will be able to execute logic closer to the users. And in web architecture, also the content delivery network, the way content is distributed to the user, is something that is also interesting. It can be interesting to understand how we can put logic closer to the users. And we are looking at how we can help people run Lambda functions in this way. So we have a project that is called, it's actually a service now, it's available in production, it's called AWS Greengrass. And it's an extension of our AWS IoT platform where you can deploy a Lambda function and run them on devices. We support x86 or ARM devices. Like last week, I was in Cambridge in an AWS user group, and we were running Lambda function on a Raspberry Pi, and it was quite fun, but it's also useful because we work with very large customers here, like, for example, Enel. It's a public utility that is present in Italy, in Spain, and South America and Eastern Europe. And they are planning to use this framework to run logic in smart gateways that they can use both for consumer, in the consumer space, and also in the industrial space.
Okay, help me understand why I want to do that, because I think of serverless as being useful because so I make a call to AWS Lambda, and what I'm actually doing is I'm making a call to Amazon's massive reservoir of servers, and Amazon is scheduling my function as a service onto whatever blob of compute is available. And the reason it's so cheap but so reliable is because Amazon has extra resources that it can schedule small blobs of compute onto. Why would I want to have AWS Lambda running on my IoT device, on my Raspberry Pi?
Because you want to go beyond two limits. One is the latency that is due to the speed of light, so we can go faster than that. And so if your device is somewhere where you have high latency on the internet, you want to have a faster response time towards the maybe other things that are connected to this client device, or you want to take autonomous decision at very low latency. And also if you want to go beyond this possible disconnection. So maybe you're building a healthcare architecture, and if you have an hospital with thousands of sensors and this hospital gets disconnected from the internet, you still want to be able to take local decisions very quickly based on the value that these sensors are reporting to you. For example, AWS Greengrass is also embedded in some of our products, such as AWS Snowball. The Snowball is like a storage device that you can order from our console. You can fill it with your data and ship it back to AWS to import data, or do the opposite if you want to export data. And the Oregon State University, they literally using this to collect data in the middle of the ocean, So they have sensors. They collect data in the middle of the ocean on a boat. And since now they have greengrass inside the snowball edge, they can start running Lambda function that can pre-process this data. And since the pre-processed data is much smaller, they can upload this data much quicker to the cloud and then send the raw data that is maybe in the order of the terabytes shipped back with the device. So it's a way to overcome the limits of latency and possible disconnection from the internet.
Cool. Now, does this help me do something like most like let's say I run so a common pattern today is, let's say I'm like a financial trading company and I've been doing trading since the early 90s, and some of my architecture that I deployed to on-prem stuff over the years has been augmented by the cloud. Eventually I saw the usefulness of the cloud and I started moving some of my architecture to the cloud, but I've still got all of this on-prem resources, and deciding what processing to schedule onto my on-prem resources versus my cloud resources maybe is not straightforward. Does this kind of green grass model, does that help me more easily do that? Because I can just say I want to schedule my jobs onto whatever Amazon Lambda device is available, whether that's on my own machines or in the cloud.
The advantage is that you have the same programming model, the same management interface as traditional Lambda functions, but then you can decide to deploy these functions on a device that is outside of the AWS data centers, of the AWS regions. And to do that, you can do lots of different use cases. Now, just the two I mentioned with the hospital and the boat are so different from each other that gives you an idea. But normally, the two drivers that we see, our customers are trying to overcome are really latency. So you want to do something at low latency. And this is especially important for some use cases. And sometimes if you want to have the possibility to continue to work even if you get disconnected from the internet. Think of in the IoT world, for example, if you think of farming, like if you have sensors that you can use for planning your irrigation systems or stuff like that, you don't want to be dependent on who is providing the internet connection to you.
Okay. Let's talk a little bit about machine learning. How can we model machine learning pipelines in a way where we can utilize serverless architecture?
And that's an interesting question. So we're working with a few customers for that. The most natural approach now is to use traditional services or infrastructure to do the training of the model, where you can leverage, for example, GPUs, so graphical processing units, or FPGAs to accelerate the training. And then when you have the model that is trained, you can deploy the model inside a Lambda function. So we have customers doing that, for example, with TensorFlow or with Apache MXNet. And in this way, you can have the production side of your machine learning project, when the consumer of the users of the model you train can get the benefit of the scalability and availability of tools like AWS Lambda and API Gateway.
Mm-hmm. You touched on the benefits of moving to serverless in terms of how your development team might be able to change. You might be able to become more agile. How are development teams changing because of that serverless movement?
This is a great question, and it's something that I always, when I talk with customers, try to also to understand on their side, and I give my own suggestion, but it's something that where I have to say more on the learning side. What I see is that with serverless, we have smaller teams that are more independent. There is more prototyping. So if you have an idea, you can quickly build a prototype, a proof of concept, and validate the idea or not. And if it works, you already are on the right path to implement scalability, availability, security. So it's much easier to move a prototype in production than from a traditional infrastructure. So this is probably the biggest change. And it's something that we also have in Amazon. I don't know if you heard about the 2-pizza team that we have. So the idea that a small team that are in charge of everything from the development to the deployment in production can give you the speed that you need when you start to grow. So it's better to have lots of smaller teams than a big team where if something bad happens, it's not clear who was in charge of that, and it's very easy to build internal dependencies that nobody is aware of.
Of course. All right, final question. You are doing lots of evangelism around serverless, and you're talking to user groups, you're talking to customers. You're seeing the bleeding edge of how people are using this technology. What are you realizing about how people are using serverless, and what are some of the cutting edge use cases you're seeing? Give me a picture for what's on the cutting edge of serverless, and what are the kinds of changes to application development that we're going to see become popular in the next couple of years?
It's always difficult to talk about the futures because the future. But what I see is that the main reasons why people is adopting serverless right now, like the speed, the agility that it gives, the possibility to build a prototype, have very limited impact cost in your cost unless you go in a large scale production environment. Those advantages will be there and are probably the driver that is bringing people to adopt this new paradigm of creating applications. We've seen customers create lots of different use cases. So from, the Vogue magazine, they created a photo Vogue in Italy. It's a platform for photographers to exchange and promote their photographic work. And it's like, it was faster in production, quicker to build, and cheaper than what we're expecting. Two other more conservative users, like the driving license government agency in the UK, they are adopting an API first approach, and they are using the API gateway to split the onion, to start to create standard interface, starter contract to interface different components, and then modularize their architecture. So it's really a variegate world that we see.
All right. Well, Danilo, thank you for making the time to come on Software Engineering Daily. It's been great talking to you. I recommend listeners check out your book, AWS Lambda in Action. And, maybe we can do another show in a year or so when the world is turned on its head once again.
That would be awesome.
Okay.
Thank you.
All right, great. Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily.
Wow!